Thank you, Bruce and Thomas. And it's good to hear there's going to be a human in the loop on that judging today. I think that's always important. Our keynote speaker today is David Johnson. David is the Senior Vice President of Manufacturing and Supply Chain Management for Nissan North America. He's responsible for managing all aspects of Nissan's manufacturing and supply chain operations in the US, Canada, and Mexico. David brings more than 20 years of experience in global manufacturing, advanced technology, and people-centric leadership. Since joining Nissan in 2002, he's earned roles of increasing importance in their operations globally. David is a 2021 Automotive News Rising Star recipient. He also serves as the chairman of Autos Drive America's 2024 Board of Directors and is on the board of directors for the Rutherford County Chamber of Commerce. He has a bachelor's degree and a master's degree in engineering from Tennessee Technology University and a master's degree in business from Vanderbilt University. So please welcome David as he discusses using large language models to capture tribal knowledge and democratize globally at Nissan. Thank you, David.
Good morning, everyone. Wow, that is super loud. I may have to stop and take a drink as I go through this because these buds and beautiful flowers that you see outside the window there, they're great to look at, but they do play a little bit of role in my allergies. So it's absolutely fantastic to be here with you this morning. It's an honor to be back at MIT with so many great people, great agenda today. But it's really an honor to share what has been going on at Nissan really over the past 7 to 8 years as we went on the AI journey. And before I jump into that, that's an updated picture. People were saying, is that picture of you, was that taken in high school? So I had to get one updated with the, I accepted purchasing as part of my responsibility about a year ago. And so I figured out a way to save money, and it was quit getting haircuts. So that's the reason for the updated picture. So I'm going to start today with a story that I had heard as a kid many times. I heard it wrongly, and actually I didn't know that it was a true story until probably about 2 years ago. And that is Charles Henry and the chalk. I'd always heard this story about this guy that came in, machine was down in a factory. He comes in, puts a white X on the machine in a particular location. Somebody comes over, hits it with a hammer, and the machine starts running. Okay, that's a great story, but I thought it was just made up. And knowing where the knowledge actually lies, well, this is actually a true story. And I hope it's okay to use one that involves Henry Ford in an area where his namesake or his big rivals, the namesake is all over the place. So anyway, the story goes, Charles Steinmetz, brilliant electrical engineer. If you don't know the story of Charles Steinmetz, I suggest that you look it up. Overcoming Adversity is pasted all over, but an absolutely brilliant guy. He was called into the River Rouge plant to work on a generator that had been creating a lot of downtime because the River Rouge back in the late 19-teens and the early 20s was the most vertically integrated plant of anywhere. They produced their own rubber, their own tires, their own energy. So this generator was giving Henry Ford fits. None of his guys could fix it. So they call in Charles Steinmetz. He spends about 2 days listening, analyzing, making calculations, and at the end of the 2 days, he takes a piece of white chalk, goes up to the generator, draws an X on it, and says to the maintenance team, replace 16 windings in this area of the generator, and it'll be fixed. Maintenance team does that. 16 windings are replaced. Generator starts back up, no issues. Henry Ford was ecstatic until he received a $10,000 invoice from Charles. $10,000 in this period of time is about $200,000 today. So $200,000 for 2 days of work. Well, Henry Ford, being Henry Ford, one of the most frugal manufacturing geniuses that ever lived, said, I need an itemized bill of this. The itemized bill comes back. It's $1 for the chalk, $9,999 to know where to make the X. Now, I tell that story because it had a profound influence on me, even though I'd heard it wrongly. I wanted to be the guy with the chalk. I wanted to be the person that knew where to make the X's. The smartest guy in the room, the guy with the answers. Well, as my career progressed, as the size of my organization grew, there was a realization that that is not what I want. That is not what I want at all. I want 30,000 people that know where to make the X's. I want the X's to automatically appear. Because the analytics, the analysis, figuring out where to make the X's, that's actually not the value add. The value add is actually going and fixing where the X's are. So how do we make that transition? Now, this is not an advertisement for Nissan, but it's a little bit about the scale of what we have in the U.S. We've been manufacturing vehicles for 42 years. And we've made over 20 million vehicles and 19 million powertrains. It's like, how do you make 20 million vehicles and 19 million powertrains? Well, we imported them in the early days, which we know that that's not a good thing anymore, so luckily we make them all here. 15,000 manufacturing associates, engineers, SCM professionals, leaders in our 3 manufacturing sites in the U.S. $14 billion invested. What does all of this mean? It means you have 42 years of tribal knowledge. Yes, we're highly standardized. We run things by the Nissan production way. However, as you go from shop to shop, operation to operation, we still have people in our Smyrna, Tennessee facility that have been there since the doors opened. They're probably not going to be there much longer because they are getting to retirement age, but we have deep, deep, deep tribal knowledge. And tribal knowledge, it's a good and a bad thing. It's one of those double-edged swords. You know that you have it, you know that you depend on it, but also you want to find a way to work it out of the system. But honestly, what we do as leaders sometimes is we perpetuate the tribal knowledge. Why? Because we send people to training classes to figure out the skills that they need to do an operation, to fix things on the shop floor, to keep the factory going. However, that's the buy you books, send you to school part. The value comes by demonstrable skills on the shop floor and knowing what to look for, how to look for it, and some history on machines, equipment, issues that we faced over time. So what do? We pair the people after we buy them books, send them to school, get them all knowledged up. We pair them with someone with tribal knowledge, on-the-job training. And then they go out and they actually learn how to do the job. That takes several years to get someone fully competent in that transfer of tribal knowledge. How can we shortcut that? How can we make a transition much faster? How can we put the power of analyzing, understanding in people's hands? Well, that was a question that we started asking as we started on our AI. And, you know, it's funny. Industry 4.0 was the buzzword back in 2015, 2016. I don't hear that so much anymore. It's still out there, but it's not there as much as it used to be. Now it's AI, AI, AI. Well, from 2015 to about 2017, we were storming, trying to figure out what to do with all of this technology, not really understanding what it was, trying to just find our way in the wilderness. Around 2018, I came back from Europe in 2017 and took over as Vice President of Production Engineering. And what I was going through in Europe was the same thing that I saw in the US, and we hit the pause button. I'd spent several million dollars in proof of concepts that really never led to anything. And we sat and we asked ourselves the question, what is it that we're trying to do? What is it we're trying to do with all of this technology? And the answer was simple, trying to make people's jobs better, to accelerate their ability to get through issues and actually fix things to make the factory run and ultimately remove the mundane task, the drudgery that is out there, and make them more effective. And so we stepped back and said, okay, what's the problem that we want to go after? And that problem was downtime in our facilities. Downtime is a killer from a cost viewpoint. It's something that I know, I don't care what kind of industry you guys are in. Downtime is a significant impact, whether it's a piece of medical machinery or something on the factory floor or hardware in ITIS. So we said, what can we do? Where's our biggest issue? Robots in body shop. So our first success story in AI, once we figured out what problem are we trying to solve and what skills are needed to really accelerate solving this problem, it was predictive analytics. Machine learning, looking at trends over time of when we had downtime events on the over 2,000 robots that we have, and this was in the Smyrna facility, it's now been broadcast out everywhere. But looking at anomalies in the data, which we had a core team of people of about 5 that would go around with vibration equipment, they would take measurements, and you know, sometimes we would catch things, sometimes we wouldn't. So putting the right telemetry collection devices on the robots, making sure that we had the data streams coming back, starting out small and then cascading it. What we did is we took the chalk that 5 people had that could go and put the X's. This is where we're going to have a potential issue on this machine. And we put it in the hands of every maintenance technician that is out there. Actually, whenever we have an anomaly on a robot, we'll know about 1 to 2 weeks ahead of time before it's actually going to break down based on the continuous training of this model. And we go, and it's not fault, find, fix anymore. It is identify, predict, fix, prevent. So every maintenance technician within the region now has access to this. They get the automatic notifications either via text or email. They're able to plan when to go in and fix the equipment on our time, not on the robot's time. Huge, huge reduction in major breakdowns. OEE increases of 3 to 4%. And 3 to 4% may not seem like much to you non-manufacturing folks that are in here, but 3 to 4% is millions and millions of dollars of opportunity. Huge success story. So we took this and said, you know, if we can do this type of machine learning algorithm on maintenance items, and also we've carried this over to just about every piece of significant equipment that we have within the manufacturing. Huge motors that run air handlers, conveyance systems. This predictive maintenance runs on everything. So we said, what can we do next? What is our next opportunity? And it was CDDS. CDDS, us in automotive, we love our acronyms, probably the same in your industry. That's chips, dents, dings, and scratches. And you guys thought it was going to be something super technical. Nope. It's chips, dents, dings, and scratches. When you have about 6,000 people working around vehicles with a lot of machinery, things happen. Sometimes the paint gets scratched. Sometimes it gets dented. And we've got in each plant close to 100 people in different areas of the shop that look for these anomalies. Now, I want you to imagine 8 hours a day with a lunch break and then a morning break and an afternoon break. Your job is to look at 450 vehicles per shift and find a surface imperfection, a piece of dirt that was left in the paint, a dent, a ding, a scratch. Super taxing, super tiring, not an easy job to do. And because of how tiring and taxing it is, 80% capability, you see it there on the screen, of a person to be able to do this type of visual inspection. That's on average. Some people will hit 87, some will be a little bit lower, and that's the reason you got to have redundancy to be able to catch and make sure you prevent the outflow. But to do that, it takes years of training, because not only are you looking, but you're also making a judgment call. And the judgment call is the real skill. It's not the the finding. That's the problem. It's the judgment call on whether is that okay from a customer perception or is it not? Because we get oversensitized to what is okay and what is not okay. Because it doesn't matter what kind of car you drive. You could drive the lowest end vehicle up to a Bentley. And I guarantee you, if I were to inspect that car, I'll find something wrong with it that you've never seen. Why? Because that's what I do. But to be able to train over 100 technicians to be able to make that judgment call that says, really, that doesn't matter to the customer, it takes a long time. Huge, huge skill. So we explored shadowgraphy, looking at light disruptions in this zebra pattern around the vehicle. And we actually started developing this in-house in Japan some years ago. And it worked well at actually identifying where the defects are. But we couldn't make a judgment call. Does it go or does it not go? So the number of defects that we found went up, but still the judgment calls were there. What we ended up doing is overlaying some machine learning, and also it's more of a deep learning algorithm. And I'm not an expert in those things, but it's more of a deep learning algorithm that goes in, and we've trained it over years on how to identify, is that a customer issue or not a customer issue? And we've actually expanded out to not only cover our CDDS, but also gap, flush, part specification. We can look and make sure that the right emblems are on the vehicle, it's the right color, etc. That skill that used to take years to develop, now we can transfer plant to plant by the algorithm and the training that's been done on it. Some of it doesn't transfer in some of the more complex areas of a vehicle. If you've got deep shapes, complex shapes, you got to retrain some of those specific areas depending on the vehicle. But for the most part, the quality that is inspected in Smyrna, Tennessee, can be the same quality that is inspected in Aguascalientes. You're not relying on the judgment calls between two separate sets of technicians. It can be exactly the same. This particular project led to about a 21 to 22% improvement in overall quality in CDDS. Why is that? Because the people that were spending hours and hours a day looking for issues, they were not let go. They were redeployed because of the trends, the massive data sets, and the ability to go in and analyze where potential issues were coming from. They were moved to go and fix those issues. So our straight-through ratio, our first-time okay rate, that's 0 issues found, increased by about 30% over this time. And that is because of the skill that was taken, democratized, deployed through machine learning, and then the redeployment of the people to a higher value use. So far, we've talked about democratization of skills, whether it's predicting when a robot's going to go down, analyzing the data that's coming off of pieces of equipment, or inspection skills. Knowledge. Skills is this is the how do I do something. I want to talk about the what. What do I do? It's a little bit of a different angle. Skills are easy to capture. Knowledge is a little bit harder. Here's a dynamic that we see quite often in our plants. The gentleman there on your left, I wanted to make sure that I'm looking at it the same way here. On your left, 30 years of experience, he's on day shift, tons and tons of knowledge. Gentleman on your right, he's on night shift. These guys see each other for about 10 minutes in the morning. Super eager, but he's only got 2 years of experience. Not a lot of knowledge. How do we cross that gap? So again, we said, where is the problem? Where can we go and find an issue to fix with Gen AI, or this one happens to be Gen AI, but with systems, with data, to be able to close the gap between night shift and day shift. We looked at vehicle electrical inspections. Vehicle electrical architecture is super complex. There's tens of miles of wires, there's tons of ECUs. Whenever you go from a base grade to a fully loaded platinum in the world that I live in with autonomous drive features, troubleshooting these when it is needed is extremely difficult. Yes, we will get a DTC, that's a diagnostic trouble code, and say this is where the issue is, but it doesn't tell you what the issue is. It could be a loose connection, it could be a bad ICU, it could be multiple things. Now, that person with 30 years experience, they'll get a DTC, they know the manufacturing process, they can go and fix it in a matter of minutes, a lot of times. The person on night shift knows the general area where to go look. What ends up happening? They end up troubleshooting with parts. Oh, I'm going to replace this, I'm going to replace that, and it becomes a long, sometimes destructive process that costs a lot of money. How do we fix this? This is the typical flow from Gen AI. So you got the human request, it goes through all of the different calculations and searches, and then it gives an answer out. Over here, the standards, repair guides, and existing documentation are our engineering documents. And we couple that with an engineering large language model, and we can get pretty good direction on where to go look for a particular issue whenever a DTC is flagged. But it's still not capturing what that 30-year technician is learning. That's where he comes in. How do we capture that knowledge? We have a system called Inspect. And in Inspect, every issue that happens from stamping, which is where the process starts in our manufacturing facility, all the way to what we call pay point 50. That's where the vehicle rolls offline. Every issue is captured. The problem is the way that it's captured is not necessarily standardized whenever it comes to how it was resolved. And that is going to be our best source of data moving forward whenever we look at the electrical inspection roles. So what we've done is we've ran this model several times, pulling in that inspect data and saying, okay, what is it that we're missing in nomenclature, standardization, to be able to go in and fix these types of issues? Because, like I said, we get good answers, but they're not perfect answers. So we're going back and restructuring how that data is input by the repairmen, by the inspectors, to standardize it to make it more easily queryable or pulled into this model. And we're starting to see some wins with it. But ultimately, what our vision is to have something that looks like this. It's just going to be a chat bot. We'll ask the question, and since we started with Charles Steinmetz, I'm going to end with Charles Steinmetz. Instead of using a boring, real-world, automotive, this is what we'd want. Instead of Henry Ford having to pay $9,999 for the knowledge and then $1 for chalk, he could just go in and ask his chatbot, hey, generators aren't working properly. causing major disruptions. What do? Boom, 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 it follows you through, and then it gets you prepared to go to work, including safety procedures to make sure that everything is working the way, or make sure that everyone is working safely. This is working at about, I would say, 50% today. And it's providing some valuable information. However, it's just another step on our journey. And once we get this fully completed, and honestly, I think it's probably going to take another 12 to 18 months to get it to where it is more valuable or highly valuable to us. But it starts with making sure that the input going in is going to be structured right and be able to be captured in conjunction with the LLM and all of the other data that is flowing into it to make it useful for our operators. But ultimately, forgot I added this slide in. This is a little bit about our journey, starting with the predictive maintenance, moving into quality control, and then in the SCM optimization. I haven't given any SCM examples today, but SCM optimization is another area where we found tremendous value out of our machine learning and analytics. Millions of dollars saved in making slight adjustments to lanes and transport on the inbound and outbound side. Also from an SCM compliance and risk with UFPLA, USMCA, those types of regulatory, very difficult to manage just on spreadsheets and paper. So this gives us full view of global disruptions, other issues that may exist out there to disrupt the supply chain. And of course, the Gen AI for electrical investigation. And then carrying those forward, process uniformity. Process uniformity is tying together all of our predictive analytics, all of the things that we do within the plant to make sure that it's uniform production, shop to shop. And there's a lot of system linking that has to be done to make that happen. Inventory optimization all the way back through tier-end supply chains. We do a really good job with what we have sight of, but through some of the visibility in the SCM compliance and risk, we said, hey, we've got visibility back through tier-end supply chain now. How can we optimize their inventory levels to support their cash flow needs, as well as hopefully provide some cost optimization as well. And then digital twins in the plant. This is the slide that I expected to be next. While I was looking for a picture of Charles Steinmetz for that first slide, I actually came across this. This is an article. It was in an Ohio newspaper in 1923. And he made the comment, by 2023, there will be no longer drudgery, and the people will not toil no more than 4 hours a day owing to the work of electricity. He visualized an amazing transformation in life in 2023. Every city will be a spotless town, and that will be the work of electricity too. Now, he didn't quite get it right, but whenever I saw that, I read about the drudgery. And the drudgery is where AI, and I like the word augmented intelligence more than artificial intelligence. Artificial intelligence sort of scares people in my world because they think artificial intelligence, I'm going to be replaced. No, we're just augmenting what is already there. We're capturing it. We're giving, the ability to accelerate learning, to accelerate fault find and fix. So for me, drudgery is the inefficiencies that exist because of a lack of knowledge. What we want to do is put that knowledge in people's hands. Give them time to go explore new opportunities. Explore other things that can be made better, to make their job and everyone else around them's job better. And time is a huge, huge limiter. But with what we've seen so far, with what's been deployed within Nissan across supply chain, manufacturing, and engineering, is time is becoming more readily available. And it's really the availability of time is where we see the drastic improvements in quality, efficiencies, et cetera, because It's really having the ability to go and analyze the true situation rather than having to focus on the problem that is right in front of you. So I say AI it's going to give us both. It's going to give us the accessibility to knowledge, whether it's tribal or something that is more structured and refined, like a repair manual, and the time that is generated is going to be absolutely invaluable. And I'm getting the 1 minute sign, so I'm going to stop there and probably have time for one question. And if you don't get a chance to ask a question, you can ask it in the fireside chat later this afternoon. Yes, ma'am. No.
How is that adoption?
Today it is okay. 7 years ago, not so much. Because Industry 4.0, whenever it first came out, and I'll go back to that terminology, everyone was afraid that people were going to be replaced en masse. But what is actually happening, and people see it on the shop floor now, I mean, we've had tons of automation come in, cobots that are working right alongside our employees, material handling automation. What they're seeing is they're not being replaced. Their jobs are actually getting better. And that day shift guy, you know what he came into every morning? Well, he'll come into what night shift can't fix. So he's got to go, he's got to repair it. So the veterans that were out there that were a little bit hesitant at first, they're not so hesitant anymore. And in the early days, what we would do to be able to get more of knowledge sharing on new technologies is I would pair veterans with bright young things. You know, folks that were just coming out of, and we had a lot of MIT LGO students that were working on projects, and I purposely would not pair them with young engineers on our team. I would find somebody that had 30 years of experience, and I would pair this really ambitious MIT LGO that's working on their project with this old, I shouldn't use the word old, but you know, experienced person that was pretty much set in their ways. And what you saw is the new, younger, more technologically advanced person was learning the process, the whys, the history of why something exists the way that it does, and being able to challenge back. And through that challenge back, the veteran was learning, there's a different way to do this. And the transformation that you see is absolutely amazing. We had one project where we were looking at identifying dents in white metal before a vehicle goes into the paint shop. And it was actually an MIT LGO that worked on this project, and nobody had ever done it before. It's a huge, huge problem to try to solve. And we actually ended up solving it. We're the first people to do white metal inspection on a moving line. And it was because of the deep understanding of the process by the LGO student from the veteran and why this was a difficult problem to solve. Without that, we would have not come to a solution. But because he understood it, he knew where to go look. He knew technologies that were new and developing that we could go and say, this may work to solve this problem. And we actually did it. It took about 2.5 years to be able to make it a reality, but that pairing is super, super powerful. But early days, everyone was very reserved. But now, you got folks from the shop floor, hey, can we do this with AI? Because they're looking, this task is awful. I don't like doing this. It's tiring. There's got to be a better way with the technology that's available. So the ideas, or at least the problems that need fixing, come from the shop floor. I would say at least 60% of the time, not out of the engineering world.
And are you seeing those teams use the same adjusting, et cetera?
It's not quite at those It's not quite at those ratios yet, but people want to take anything that is time-consuming, repetitive, and I would say somewhat predictable, and push it into the automation. And I guess I've got to stop there. But again, if you've got any questions, I can answer them at 11 o'clock later today. But thank you very much.
Yeah.
I don't know where this goes, Bruce.
Perfect. Thank you very much.
Thank you, sir. Thank you. Thank you.
Okay, well, thank you very much. And yeah, I do remember that project that he was talking about the white metal. Bobby worked on that. It was one of the first MIMO projects, actually, or that MIMO was involved, or I was involved. So really impressive to see that, that final inspection come to light the way it did. So next we want to talk a little bit about the data, all right? And so